This video we will be going over section 2.2, which is on inverse trig functions. The topic here, the main topics, inverse, sine, cosine, and tangent functions, what they mean, and there are some special things about them which we'll see. Then we'll talk about determining expressions and values involving a trig and inverse trig function. This is an application of trig functions that actually, and inverse trig functions that is pretty frequently seen in calculus. So that's why we really do it. We won't see it much for us here in this class personally, but for those of you taking calculus, you will see these kind of questions. Applications of inverse trig functions. This section here basically builds on section 1.4 when we started talking about right triangles. One of the things I mentioned is that we do not know how to figure out the angle of the right triangle unless if we have the other two, and we do that 180 minus the other two angles. So this is really what inverse trig functions are used for, is they're used for solving for angles or whatever the content inside the trig function represents. So the first thing I have here pointed out, as you can see below, the inverse trig functions are used to determine angles in a right triangle. It really branches from SOHCAHTOA. If, one of the main points that we talked about was that it works with right triangles. So when we deal with inverse, sine, cosine, and tangent, they can, and we'll see that they pop up in some other places, but we typically only use them in right triangles, or if you're solving an equation, which we'll see in the next section. But there is a lot of little things to talk about here. Understanding what the inverse trig functions do when you plug it in your calculator with a number and what you get out is very meaningful. And we don't want to think about the first set of problems, which is just using your calculator, as just a calculator problem. We want to understand what that answer means, what it's telling us. Right. So the first thing, the notation, the inverse sine function, all the other trig functions are the same. It looks like sine to the -1 power of x. Now, one thing I'll go ahead and mention, I'll look at the calculator here. I mentioned this in the previous video, but on the sine, cosine, and tangent functions, you have the to the -1 power on them. These are going to be the inverse trig functions. And we're pretty much only going to see sine, cosine, and tangent. The last topic here about the other three is just me talking about why you don't really need to worry about inverse secant, cosecant, and cotangent. Right, we're not skipping out anything that's important. Right. So what I want to do is start by giving this some meaning. And one thing I will say is most of the time you want to be in radians, because when you deal with the inverse trig functions, it spits out an angle. Right? That's what they're used for. They spit out an angle, and 99% of the time you're dealing with an inverse trig function is because you're solving something that is, related to a word problem, related to an equation. The inside is understood to be radians. We'll see some word problems at the end of this section where there are degrees because it's a triangle and we want to visualize it. But the first thing I want to do is just kind of walk through one example and what it means. All right, so let's plug in sine inverse of 0.3 into our calculator. So we hit the second button because it's right there, sine inverse, and we got 0.3. And I'll double check I am in radian mode. If you're in radian mode, you should get 0.3047 if you round to 4 spots. And to understand what your calculator did, just very specifically to these numbers, what happens if you do sine of your answer? So sine of 0.3047, it's rounded a little bit from what we got, but you will get about the 0.3 back. All right, so what your calculator is spitting out here, it's spitting out the angle that make well, it's spitting out one of the angles that makes sine 0.3. Right? So when we see something written like sine inverse of x, it's going to spit out an angle y that makes sine of y about x. Right? It's pretty confusing in words and in symbols when we start, because it's just not very natural. It's something we're not very used to. So that's why I have written here in words. What it's giving us is it's giving us the angle where sine of y equals x. Sine of 0.3047, our answer equals 0.3. Right. So first thing we want to touch on is that we're getting a number out. That number is an angle, and the way it's related is it's an angle that makes sine equal the number inside. Okay. Now, one thing that we'll see going forward, and we'll have to talk about pretty quickly anyway, but there are a lot of angles where sine is about 0.3. If you do sine of 2.8369, we'll see how to figure out this number in the next section. We've actually kind of talked about it already, but that's also about 0.3. Right? Because sine is going to equal 0.3 for infinitely many numbers, infinitely many angles. But our calculator is only going to give us one, specifically this one, 0.3047. Right? Why it's giving you one number is because, excuse me, it's because the inverse trig function, it's a function itself. What being a function means is if you plug in a number, you get out a number. You plug in one thing, you get out one thing. All right, so I have this little chart here. I think taking a picture or writing this chart down is very important. And I have some extra stuff in here. I thought I deleted this, so my apologies. I'm going to edit this real quickly. I don't need this stuff written. I'm just going to edit this out, scratch through that. But we're going to talk about sine, cosine, and tangent inverse trig functions. The notation is just the same notation as the regular trig function with the -1 power in there. The output meeting, it's always the angle blank. Whatever we get out is the angle theta that makes sine of theta equal x for sine inverse. If we're dealing with cosine inverse of x, the number we get out is the angle that makes cosine of theta equal the x. And the tangent inverse is we get out the angle that makes tangent of theta equals x. And because we have so many possible angles and our calculator only gives out one, the way you can figure out which one it's giving you is from here. All right, so the quadrants of the output, meaning the angle you get out for sine inverse is quadrant 1 and 4, but specifically you get an angle between -pi/2 and pi/2. Right, so we're not thinking about the regular 0 to 2 pi when we talk about the inverse sine, because it really boils down to the fact that -pi/2 to pi/2 is just one connected part. If we wanted to do quadrant 1 and 4, but 0 to pi/2 and then 3 pi/2 to 2 pi, it'd be kind of awkward and not very meaningful. So that's why your calculator gives you something in here for sine and tangent inverse. You'll see that tangent is the same. Right. So when you type in sine inverse or tangent inverse into your calculator, you get out an angle, and it's between -pi/2 and pi/2, or quadrants 1 and 4 for sine and tangent. Right. The reason these are chosen is because one of the quadrants, quadrant 1, is where they're both positive, and quadrant 4 here is where they're both negative. Right. Now for cosine inverse, we use quadrants 1 and 2, and that's from our regular 0 to pi, because that's, 0 to pi is just like this connected interval. So they all use cosine, or they all use quadrant 1, but cosine inverse uses quadrant 2 because x is negative over here. And then we use quadrant 4 for sine and tangent. The sine is more easy to understand. It's because y is negative here, but positive in quadrant 2. So we don't want two quadrants where sine is positive. The reason tangent is like this is because tangent's not defined at pi over 2. You don't need to memorize that or deeply understand that. You just want to memorize, when you type in your calculator, what is it telling you. All right, and once again, I'll reiterate, it's very important when you do inverse trig functions that you're in the correct mode. You'll have to be told in the problems which mode to do, unless if it'll be written somewhere. Right. But we just have a few problems, mostly calculator, but we want to understand what it's giving out. So you'll see questions like this. Evaluate the following in radians in your calculator. Round your answer to 2 decimal places. Additionally, state what quadrant the angle is in. Right, so this is very important. If you can do the calculator part, pretty much, that's kind of thoughtless. You just type this in your calculator. But it's really important to know what it's putting out. It's putting out an angle in some quadrant. Right, so that's why we're going to focus on this first. All right, so we'll start by just typing this in our calculator, and then we'll talk about the quadrant thing. We want to do cosine inverse of 0.48. It says to do radians. Like I said, it will be in the directions. You just have to pay attention. Cosine inverse of 0.48. We get 1.07 rounded to 2 spots. It equals 1.07 rounded to 2 spots. Now, one thing to remember, this is coming out with an angle, which doesn't mean it has to be between -1 and 1. In fact, the number inside here will be between -1 and 1, or we'll see an error. And I can just show you that on the side. Right? But that's the answer to the question, what is this? It equals 1.07. We just plug it into the calculator. Now the question is, what quadrant is this in? Right? It is an angle. And there's 2 ways you can do it. One way is the old way. We're in radians. So if we go ahead and write down our radian chart, and if it helps, write the decimals. I have written them enough. I have them memorized. 2 pi is about 6.28. Pi over 2 is about 1.57. Pi is probably the one we all know, 3.14, and 3 pi over 2 is about 4.71. But definitely it's between 0 and 1.57, so it's in quadrant 1. All right, and this is one way to do it. The other way to do it is by its definition. And it's totally up to you which one you want to do. I'm not particularly fond of one way or the other, just whichever one makes more sense. This just requires us to use some old knowledge, which is kind of nice. It builds on what we've done. The other way is that we know the answer to cosine inverse of anything is in quadrant 1 or 2. Right, that comes from our chart up here. And in quadrant 1, cosine is positive. In quadrant 2, cosine is negative. Right? All these quadrants are chosen so that one's positive and one's negative. And what we're asking here is, what angle is cosine equal to 0.48? Since 0.48 is positive, it must be in quadrant 1. Okay, because we're trying to figure out what angle in quadrant 1 or 2 is cosine equal to 0.48. Since it's positive in quadrant 1 and negative in quadrant 2, it has to be quadrant 1. Right. Now you can do it either way. If you get comfortable with this way, it's definitely much quicker, but you'll also get so used to the numbers of, you know, what is between 0 and pi over 2 and everything else that it might be better for you to do it this way. But there's not an advantage of one way over another going forward. Just figure out one that works best for you. All right, either way, it's quadrant 1. All right, number 2 here. Same directions. We want to type this in our calculator in radian mode. Cosine inverse of negative 0.67. And we get 2.31 rounded to 2 spots. Once again, this is an angle. It's always going to be an angle between 0 and pi for cosine inverse. And the question is, what quadrant is this in? And you can do it either way. It's really up to you. You know, like I said, it's not a bother to me which one you might prefer. I think maybe if I had to guess, I honestly don't remember when I learned this stuff which one I liked, because it's been too long at this point. But I would guess that I liked just making the chart and comparing the numbers like this, and not trying to use the negative and positive thing too much. Right, but we can see the angle 2.31 is between 1.57 and 3.14. So it is in quadrant 2. But we can also figure it out the other way. We're trying to figure out where cosine's negative. Out of quadrants 1 or 2, cosine is negative in quadrant 2. Right. I just got one more here for, excuse me. I just got one more here for sine and tangent inverse to practice those. It's really just hitting another button, but since they have different domains, it's good to, or ranges rather, it's different to, it's good to do the different ones. So I got sine inverse of negative 0.29. And what we get is negative 0.29. It's coincidental that it's the same one. That's not always the case. And yes, you can get a negative because the outputs for sine and tangent inverse are quadrants 1 and 4. I'll remind you that. Sine and tangent inverse are between negative pi over 2 and pi over 2. And this one, it's probably best just to realize what quadrant this is in. This is in quadrant 4. It's between negative pi over 2, which is about negative 1.57, and 0. All right, when you draw the picture for this out, since it's negative, you wouldn't really have our normal picture. We would have to include the actual range of sine inverse and tangent inverse, which is negative pi over 2 to pi over 2. Right, but it fits right there. It's in quadrant 4. All right, but this number, it can't be in quadrant 3. It cannot be in quadrant 2 because it can only be in 1 or 4. Also, because sine is negative in quadrant 4 and everything's positive in quadrant 1, it's got to be quadrant 4. All right, so the last one we got here, tangent inverse of 3.24. Right, we talked about briefly before that tangent can be anything. So when you do tangent inverse, the inside can be absolutely anything. tangent inverse of 3.24, we get 1.27. And what quadrant is the angle 1.27 in? Well, once again, if you want to draw the picture, you've probably seen a few enough, at least quickly enough by now that you know what it's going to be. But since tangent inverse is between negative pi over 2 and pi over 2, it's in quadrant 1 or 4. You can see that it's between 0 and 1.57, so it is in quadrant 1. Right. One of the easiest things to remember, especially if you do this enough, when you do any inverse trig function and the inside's a positive number, the angle's always in quadrant 1. If the inside's negative but you have sine or tangent, it will always be in quadrant 4. If the inside is negative but it's cosine, it'll be in quadrant 2. Right, but it's really important to understand what's coming out. The angles are coming out, and we want to be able to recognize what quadrant those angles are in. It's very, very important. All right, so the next few we've got here are just some exact value ones, meaning we don't want to use our calculator here. You can use your calculator to check your answer, which is what I'll show you. But it's very nice to have the wording when you're dealing with this. Right. I should have gotten rid of this part of the directions because I separated the two sections. My apologies. So it says for the following, evaluate, give exact answers in radians, and there's no if possible anymore because I moved all the other ones above. All right, so the first thing, sine inverse of 0. You know, if we want to do this without a calculator, we got to use our wording. What is this asking us? Well, we know it's an inverse trig function, so we want an angle. Because we're talking about sine inverse here, we want an angle between negative pi over 2 and pi over 2. Right, that is what comes out from sine inverse is an angle between negative pi over 2 and pi over 2, where sine, I'll call the angle theta. Sine of theta equals 0. Right, we want the angle where sine of theta equals this inside number 0 between negative pi over 2 and pi over 2. Now it's definitely helpful to draw your picture out. Negative pi over 2 is down here, then 0, then pi over 2. So we want to get the angle between negative pi over 2 and pi over 2 where sine of theta equals 0. Right? And if you're ever doing these exact value ones, it's nice to draw this picture. For sine and tangent inverse, it's between negative pi over 2 and pi over 2. For cosine inverse, which is down at number 2, it's going to be between 0 and pi. I'm just going to go ahead and draw on the pi one as well so we can reference for the next problem. But the angle between negative pi over 2 and pi over 2, whereas sine equals 0, is 0 itself. Right? Because the coordinates here are 1, 0. So we have sine of 0 here equals 0, the y value. And if you type this in your calculator to check your answer, you'll see that sine inverse of 0 does equal 0. Right, now down to number 2, cosine inverse of negative square root of 2 over 2. We want the angle theta, whatever we want to call it, between, since we're dealing with cosine inverse here, it's between 0 and pi, where cosine of theta equals that negative square root of 2 over 2. Right? Now, if we're in quadrant 1 or 2, cosine is negative, is automatically going to put us in quadrant 2. And the reference angle for square root of 2 over 2 is pi over 4, right, in radians. So that's why I'm using radians here, pi over 4. And we've got our angle here, pi minus pi over 4, which is going to be our answer. And this, we can get a common denominator and get 3 pi over 4. And so cosine inverse of negative square root of 2 over 2 is 3 pi over 4. You can also check your answer here. Like I said, this one's pretty straightforward. You type in sine inverse of 0, we'll get 0. Might as well do that just so you can see. But that's a nice number. You know, you don't have to compare a decimal. If you want to check your answers here, you know, there's kind of two ways to do it. I like to just do the direct thing. Type in cosine inverse of negative square root of 2 over 2. So we got negative square root of 2. And we want to divide that by 2. You're going to get a decimal because it's from that pi. And we want to see, is this the same as 3 pi over 4? So we compare that decimal to 3 pi over 4, and we do get the same thing. So it does check out. Now, doing tangent is very similar. One thing I mentioned in a previous video was that while we didn't need to learn the exact values of tangent right then and there, it was good practice to look at that. So I'm going to just remind you of what those are. Remember, tangent inverse is an angle between negative pi over 2 and pi over 2. So I'm going to draw that in. And the reference angles of pi over 6, pi over 3, and pi over 4, the tangent values are as follows. Tangent of pi over 6, and that's sine of pi over 6 over cosine of pi over 6. It's 1 over the square root of 3, which is the same as the square root of 3 over 3. All right, this is something we talked about before, so I'm not just making this up out of nowhere. Tangent of pi over 4 is 1. And tangent of pi over 3 is square root of 3. If you come down here in quadrant 4, right, all these angles are just negative of the angles up here, tangent of negative pi over 6. And because of the reference angles being the same, the only thing that changes is the sign. Tangent of negative pi over 6 will be negative square root of 3 over 3. Tangent of negative pi over 4 will be negative 1. And tangent of pi over 3, negative pi over 3 rather, will be negative square root of 3. So when you're dealing with tangent inverse, these are most of your possibilities. We could still, of course, have 0 here. Tangent of 0 equals 0. If you try to type in tangent of pi over 2 and negative pi over 2, you will get an error because it does not exist there. All right, but I just want to draw that picture in here as a reminder because I know we haven't dealt with this nearly as much. But if we want to answer the question here, what is tangent inverse of 1? We want the angle theta between negative pi over 2 and pi over 2, where tangent of theta equals 1. Because I have the chart here with every possibility, you can just look at the chart. It is a good idea to try to remember the reference angles. We talked about this before. But tangent of theta equals 1, where theta is pi over 4. So that's right there. Tangent inverse of negative square root of 3 over 3. We want the angle theta between negative pi over 2 and pi over 2, where tangent of theta equals negative square root of 3 over 3. and that is negative pi over 6. Once again, I highly encourage you to check your answers here. It's not a terrible thing to do. And in a lot of ways, you can kind of think of these ones with exact values as almost like multiple choice questions, because you only have so many possibilities, and if you get stuck, you can just type this in, see which one it might match, because we only have these angles as choices. But let's go ahead and do tangent inverse of 1. Is that the same as pi over 4? Yes, it is. So that one works. And then the other one, tangent inverse of negative square root of 3 divided by 3. Oops. And is that the same thing as negative pi over 6, what our answer was? And it is. Right, so I would definitely encourage you, even with sine and cosine, you can kind of think about the angles and what they can be as well to help you out with these, but especially tangent. We didn't deal with tangent as much. If you remember the reference angle thing, it helps a lot. Reference angle, when it's pi over 6, pi over 4, and pi over 3, we get these values for tangent. The difference in quadrants changes the signs between positive and negative. All right, so the next thing I mentioned at the beginning, a surprisingly common application of trig functions is evaluating a composition of a trig and inverse trig function. And as an example, you can see here what's going on. When we say a composition, that's when you had two functions and you did one inside another. So we're doing an inverse trig function inside a trig function. Now the idea here, you're not going to be able to type this into your calculator and get an exact answer, meaning if I type this into my calculator right now, I'll tell you right now I'll get a weird decimal and that will not work as our answer. But you can see that these problems are built into 2 steps. We want to figure out an expression, find a simplified expression for the expression cosine of tangent inverse of b over 8 without trig functions. So we're going to get rid of the tangent inverse and the cosine. We'll get a formula for that. And then what we'll do in the second part to figure out cosine of tangent inverse of negative 5 over 8, we'll plug in b equals negative 5. All right, but I have outlined above how we go about doing this. You always work inside out. So we do the inside part. And doing this inside part might not make a lot of sense at first because really we have a letter here. You can't type this in your calculator, but it does tell you something to draw. You can always draw a right triangle. So what we want to do is draw a right triangle with an angle theta where tangent of theta equals b over 8. All right, so remember what the inverse does is it spits out an angle. Tan inverse of b over 8 is going to give us an angle where tangent of that angle theta equals b over 8. And this is where SOHCAHTOA comes back in. All right, so we got our angle here, a right triangle. We got our theta. Just call it one of the 2 angles that you have. It doesn't matter which one. And tangent is opposite over adjacent, SOHCAHTOA. So we're going to label the opposite side as b and the adjacent side as 8. Now, as weird as this sounds, this is the inside. You've done the inside part. Doing the drawing a right triangle and labeling it is the inside part. Right? So once you take care of the inside part by drawing your right triangle and labeling the sides, then we want to do the outside part, meaning I want to get cosine of theta. We want to get a formula or an expression for cosine of theta in our triangle. And we know cosine is adjacent over hypotenuse. Right, this is our adjacent side, is 8. But our hypotenuse is what we have to figure out. We need a formula for the hypotenuse. So we do what we did before. To figure out the hypotenuse, we want to use Pythagorean's theorem. Because you have a b here, there's going to be a formula with b in it. It's not going to be just a number. We have a squared, which is 8 squared plus b squared, which is actually labeled as b, equals c squared, which is the hypotenuse squared. Once again, remember that we are solving for c here, what we're calling the hypotenuse. Since it's already c squared, you just square root each side. Be sure that you square root the entire thing here. You cannot break up square roots over plus or minus. And when we do the square root, it knocks the squared off the c. So we got our formula for c. The square root, 8 squared is 64, and b squared, since we don't know what b is, that's what it is. So c equals the square root 64 plus b squared. All right, but now that we have our adjacent side, which was 8, and our hypotenuse, which is 64 plus b squared, we have our answer for part A. Cosine of theta equals 8 over the square root 64 plus b squared. All right, so that's what goes here. Remember, this inside is what theta is. So cosine of theta, we're talking about the first part here. Cosine of theta equals 8 over the square root of 64 plus b squared. All right, so once again, I have the general strategy outlined here. You take the inverse part on the inside, you draw a right triangle. You're almost always going to have to figure out the third side using the Pythagorean theorem, and then you figure out the outside part. All right, now to get part B, cosine of tangent inverse of -5 over 8, we plug in -5 for B, because that's exactly what this is. Okay. So we got cosine of tan inverse of -5 over 8. We have our formula with b in it from part A. We got 8 over the square root of 64 plus, and then we're plugging in -5. Don't forget to square this. -5 squares 25, and 25 plus 64 is 89. Okay, so our answer here is 8 over the square root of 89. Right. We did all our work on the left side, and then put in the answers on the right side. Right, but once again, just to recap one more time, because I know at first this is very confusing. We take the inside inverse part, we draw a right triangle depicting that. Tangent inverse of b over 8, we have our angle theta. Tangent of theta is b over 8. We figure out our third side, which happens to be the hypotenuse here. get a formula for that with our beginning letter of B. Then since we have cosine on the outside here, we do cosine of theta, which was adjacent over hypotenuse, and we write that down and plug in our formula. Then the second part, how you actually deal with numbers, is just like this. You take your formula, you plug in B appropriately. Right. Now, one thing I'll go ahead and do is just show you that this equals each other. Right, so let's see, what does cosine of tan inverse of negative 5 over 8 equal? So we got that. Is this the same thing as 8 divided by the square root of 89? And it is. Right. But this is not the right answer because we need the fraction. We do not want decimals. There's no way you're going to take this number here and be able to figure out it's this. Right. But just got one more to do here, because sometimes when the inside doesn't look like a fraction, you just really make the subtle fix of making the inside of numbers, whatever it is, over 1. But we want to do the same exact thing as last time. We take the inside, which just happens to be tan inverse again. It could be sine or cosine inverse. And we want to draw a triangle, right triangle. With tangent of theta equals x. And like I mentioned, I'm going to think about it as being x over 1. So we got our angle theta here. Tangent is opposite over adjacent, just like before. So our opposite side is going to be x. And our adjacent side is going to be 1. Now we want to do cosecant of theta. So we need the hypotenuse. And we just do that exactly like last time. We want to figure out hypotenuse. And we do that using the Pythagorean theorem, a squared plus b squared equals c squared. We got 1 squared plus x squared equals c squared. And we're solving for c. We already got c squared by itself. We do the square root just like last time. We got the square root of 1 plus x squared equals c. And that is what we plug in. So we got the hypotenuse is square root of 1 plus x squared. Now cosecant of theta is flipping sine. Right? Since sine is opposite over hypotenuse, when we flip that, we get hypotenuse over opposite. Okay, so that's how you want to really interact with all this stuff. We flip sine of theta, sine, so katoa, sine is opposite over hypotenuse. We flip that. And then look at the formula. We would get hypotenuse is the square root of 1 plus x squared. And the opposite side is x. All right, so our answer, cosecant of tan inverse of x, is the square root of 1 plus x squared over x. Now this one didn't ask us to do anything with numbers, plugging in something, so we don't have to do that. But if you wanted to figure out cosecant of tan inverse of 4, for example, then you would plug in 4 for x, just like last time. Right. The last couple things we have here are applications of inverse trig functions, and really it boils down to if you have a word problem or if you have a triangle, now we can figure out angles that we could not do before. Right, and that's my reminder here. Remember that inverse trig functions are used to figure out angles, so we'll now be able to solve for missing angles. All right, so it says for the right triangle below, suppose that A equals 4 and B equals 3, and we want to figure out side C, angle A, and angle B in degrees. I'm going to go ahead and point out that because the degree symbol there, if we have to use our calculator at any point, we want to make sure we're in degrees. But we can figure out C without doing anything besides the Pythagorean theorem. So to get C, we got C squared equals A squared plus B squared. Four squared plus 3 squared, 16 plus 9 is 25. So C squared equals 25, and then we finish with the square root. And we got C equals the square root of 25, which is 5. So I'll remind you once again that when we deal with all this stuff, the hypotenuse, or if we have a triangle already, we don't have to worry about the negative sign. I forgot to mention it on these problems here, but the reason we don't have to worry about doing plus or minus when we do the square root is because of the x. Okay, because we don't know what x really is, there's no way we can actually figure out whether we should do the plus or minus. It'll take care of itself, for lack of a better term. All right, but C is 5. Let's go ahead and write that in. Now we want to get angle A and B. Now, there's a lot of options to figure them out, but let's say we want to do angle A first. What I would do here is notice I have all three sides. I can set up an equation with any of the trig functions I want and be able to solve for A, because I can do tangent and I have opposite over adjacent. I can do sine, which is opposite over hypotenuse, or I could do cosine, which is adjacent over hypotenuse. And it doesn't matter which one you choose. I'm just going to use cosine for no other reason than that. So cosine of our angle A, once again we're solving for this so we can't plug it in, is B over 5. Or sorry, 3 over 5, because we know B is 3. Right. Now, what happens here to get A by itself, to get cosine to go away? Right. What we do is we do the cosine inverse of each side. Right. Inverse functions make the regular function go away. So visually what I'm talking about here is I'll do cosine inverse of both sides. And what goes inside are exactly that, both sides. We got this. Right, so we had cosine of A equals 3 over 5. We do cosine inverse of each side. And once again, the reason we do that is because inverse functions cancel out with the regular function. All right, so this goes away. That always happens. The inverse function cancels out with its normal one. The inverse function to the squared is the square root, which is why squared cancels with square root. But we now have A by itself, which is what we wanted to solve for. We have A equals cosine inverse of 3 over 5. And then we type this in our calculator. But because we want it in degrees, we got to make sure we're in degree mode. Right, so we want degrees. We want to make sure we're in degree mode. Go over and hit degree, quit. And then these we wanted to do, I hit the wrong button. cosine inverse of 3 divided by 5, we get 53.13 degrees. Now, if you had set up an equation with sine or tangent, you'd have different numbers over here, but you will get the same answer. All right, now for angle B, since now we have 2 of the 3 angles, you can still do something with the inverse trig functions, or you can just do 180 minus the other 2 angles. And I pretty much would say, unless if you really want to practice the new stuff, which there's nothing wrong with, just, keep in mind that angle B would be 180 degrees minus the other. We got 90 degrees from our right angle and minus 53.13 degrees from the angle we just found. All right, it's going to be the quickest way. So we get 180 minus 90 minus 53.13. I get 36.87 degrees. Right, because the angles in a triangle always add up to 180. It doesn't matter exactly what it looks like. Just as long as it's a triangle. Right. But you can use the other way to practice. The main thing we're looking at here, if we need to figure out an angle in a right triangle and we're missing 2 of them, you're going to have to use an inverse trig function. But you still have all your other old tools. All right, so the last question in this section is just a word problem. It says a guy wire is 1,575 feet long and is attached to the top of a tower. All right, so I'm just going to draw that picture. So far we have some tower. There's my beautiful tower. And we have our wire attached to the top. And when it's pulled taut, it touches level ground 607 feet from the base of the tower. So we take our wire here and we bring it down to the ground. It hits the ground here. This is our wire, which is 1,757 feet. And it hits the ground. This forms a right angle because the tower's, it must be vertical at least because they don't tell us otherwise. And it hits the ground 607 feet away from the base of the tower. So this bottom side, 607 feet. The question is, what angle does the wire make with the ground? All right, so you got to read this carefully because it'd be very easy to think you're figuring out this angle, but this is the angle between the tower and the wire. That's not what it's asking. It's asking for what is this angle. Right. So it's going to ask for one of these 2 angles because we're learning about angles, but you have to just be very careful. Which one is it actually asking for? And once the angle the wire makes with the ground, and you can read this one, how they want our answer. Express your answer using degree measure rounded to 1 place. Okay, so what we do is we want to set up an equation to solve for theta. And what you want to notice here in relation to theta, we have adjacent and the hypotenuse side. We don't know how tall the tower is. We're not asked how tall the tower is. We don't care how tall the tower is. We just want to figure out theta. So we want to use cosine because we have adjacent and hypotenuse. We've got cosine of theta equals 607 over 1,757. One thing I would definitely say here is don't worry about trying to write this as a simplified fraction. If it does simplify, this might already be simplified. Just directly, you want to get theta, you want to get the cosine to go away. by doing the cosine inverse of each side. All right, so once again, I'll write what it looks like just to really push the point home of what we're doing, what it's being used as. That the cosine inverse and the cosine cancel, we get theta equals cosine inverse of 607 over 1757. And theta, what does that equal? It's in degrees rounded to 1 decimal spot. Cosine inverse of 607 divided by 1757. And we get 69.8 degrees. So like I said at the beginning, when you're dealing with inverse trig functions, they're used to solve for angles. You need to be careful if you're in the correct mode or not. You will be told which mode to use some way in the problem. Right, but we'll use this pretty quickly going into the next section because that's on actually solving trig equations. But if here we have finished all the material, this next page I just have to talk a little bit about why we don't ever really deal with inverse, secant, cosecant, and cotangent. And I really have it all worded out, but I just wanted to talk to an example for those that are interested. All right, so suppose you wanted to find the value of cosecant inverse of 3, but you don't have a cosecant inverse button on any calculator usually. You won't find it, and you don't want to do it in the way you might think, which would be 1 over sine inverse of 3. I should probably write that in. All right, that's not the way these inverse functions work with their reciprocal functions. That's why they are tricky and why you don't really want to deal with them. But in words, what this means, cosecant inverse of 3, means find the angle theta where cosine of theta equals 3. Right? The same idea applies for all 6 of our trig functions and their inverses. The interpretation is the same. Since cosecant of theta is sine theta flipped, this is the same as asking the question, find sine of theta, find theta for sine of theta equals 1/3, because we flip the 3 and we get 1/3. And then if we take that back and relate it to our inverse, what this is saying is if we did sine inverse of each side, theta equals sine inverse of 1/3. All right, so therefore, evaluating cosine inverse of 3, the way you do it is really you evaluate sine inverse of 1/3. In general, you flip the inside to evaluate the inverse of the reciprocal function. So ultimately, you do not have to ever learn anything about cosecant inverse, cotangent inverse, or secant inverse. But this last line tells you how you would do it without your calculator. Well, without a button for it on your calculator.